Alternating current or AC supply is everywhere. The house that we have, we get AC supply. The industries we work in gets AC supply. The transmission and distribution of electricity happens using AC supply. Even the generation in the power plant happens in AC supply only. But if you open the control box or the low voltage box of any electrical installation, let's say, for example, a switchgear panel, you will notice in that box, the complete circuitry is controlled by direct current supply or DC supply. Now, the question is, when the whole power system, the whole world is using AC supply, why we need DC in control circuitry? And in this video, I'm going to clarify that thing to you. And by the end of this video, you'll have clear idea why DC supply is preferred over the AC for control and protection circuitry. This lesson is from my course Circuit Breaker Control Schematic Masterclass, the course in which I teach you how to read and interpret the control schematics of any circuit breaker up to 800 kilovolts. If you're interested in learning about the circuit breaker control schematics, then do check out my course. You'll find link for it down in the description. Now let's go ahead and talk about why DC supply is used in auxiliary systems. Now you take any electrical installation, you can take low voltage switchgear, medium voltage switchgear, or the high voltage switchgear. There are two different kinds of ratings you will find on them. One is the rated normal voltage and another one is the auxiliary voltage. Now rated normal voltage is the voltage for which the switchgear is designed. It's the system voltage. So if we take the example of medium voltage switchgear, it could be 12 kV, 24 kV, 36 kV, or 52 kilovolts, right? And then we also have auxiliary supply, auxiliary voltage. Now this voltage is different than that of the rated voltage. Auxiliary voltage, we use it for powering our control and protection circuitry. And it is much lower when we compare it with the rated normal voltage. Now, if you look at the panel of medium voltage, it is clearly divided into two parts. One is the power circuit. For example, here is the power circuit highlighted by orange color. You can see this is the circuit which will carry huge currents, heavy voltages. And then we also have a control circuitry which will have much lower voltages compared to the power circuit. Now, a lot of people call power circuit as the main circuit and the control circuit as the auxiliary circuit. So these names are interchangeably used. But if you open this box, the control box or the low voltage compartment of the medium voltage switchgear, you will find DC is used everywhere. The alternating current supply for control and protection circuitry is very rare, right? So that's the situation. Now, if you have to remember this, you can take a simple analogy of a car. Now, car is capable of generating a huge power. The engine of the car can handle a lot of mechanical power. There is no problem with that. But do we use that same mechanical power, that's huge horsepower, to also start the engine? No. What we do is we simply use a simple command which we give to a spark plug, and then the spark plug does the next things. So to start that huge machine, to get that huge horsepower, we just need a small control input to kick things in, right? The same analogy is also true when we say the power circuit and the control circuit. Power circuit will carry the huge currents, it will handle the heavy loads of the voltage, no problem. But to control that thing, we need a different voltage. We need a smaller voltage, and that basically is the auxiliary voltage, and that basically is always, all the time, is direct current. Right now, the question is how will they control? Of course, they will not do the switching and all. But for example, if we talk about the circuit breaker, the control circuitry will give command to circuit breaker when to open and when to close. So that control is done using the control circuitry, the auxiliary circuitry. And this is where the DC is used. The question is why? Well, the major reason for is that the direct current can be stored. Let's take one example. Imagine this is a 36 kV panel and all the bus bars, all the other terminals are carrying 36 kilovolt. And you also have a control circuitry, of course, and you also power that control circuitry using alternating current. Let's say 230 volt AC, right? Now, let's say there is a short circuit. Now, of course, because of the short circuit, one thing is the current in the system will shoot up to a very high level. We all know about that. And because of that, the power supply will also not be there, right? The power will lose the power. So if we lose the power, the control circuitry will also lose the power, and they won't be able to give the command to the circuit breaker to open. The relay won't be able to operate, the relay won't be able to give the command, and as a result, the breaker will stay in closed condition even when the supply, even when the fault is there, even when the short circuit is there. And if that short circuit current keeps flowing into the system, it will damage the equipment, it will damage the whole system, and there is a possibility of fire as well, right? And that's a big problem, and for sure we do not want to have that situation at any cost, right? And the problem with AC supply is we cannot store it. So how do we have the backup in case the power goes? Because tripping off circuit breaker is one of the most crucial operations. The circuit breaker must trip in any condition to safeguard the system, of course. So that is the reason why the direct current and or DC is preferred to control and monitor, or to protect the system, because DC can be stored into batteries. And that is the reason why you will find that's one reason. Of course, there are multiple reasons, and this is not limited to the medium voltage panel that we talked about. You open low voltage panel, you even go to the high and extra high voltage substation, you will find dedicated battery banks are there to supply the auxiliary voltage that we need for our system. So that is one of the main reason why the DC supply is used. But of course, there are other reasons also. Now, if we look at the auxiliary circuit or the control circuit, let's list down some of the requirement it has. Well, the first requirement we saw, okay, it must operate during the power failure. That is one we already talked about. Then it should have an instant response and steady supply. Now we were talking about circuit breakers. Now circuit breakers open and closing command depends on the simple coils. We have closed coil and trip coil, and that coil needs a steady supply. If that is not there, maybe the breaker will not open, or maybe the breaker will not close. So we need a steady supply there. So that is another very important requirement of control circuitry. Second, voltage stability. We are talking about relays which are very sensitive to voltage fluctuations. If voltage fluctuates, there is a high possibility that the relay may malfunction. Relay will not give the desired output that we want. So we need voltage stability, very important. Third is component compatibility. Now if you open any of the switchgear's low voltage compartment, you will find the contactors, the relays, most operate on direct current and not the alternating current. So a voltage must have those component compatibility as well. And some of the components just cannot operate on alternating current. For example, a coil. Now, a coil needs a steady state supply to generate a steady state magnetic field, and then only it can attract or repel the plunger that it has. If we give AC supply, an AC will produce alternating field, which is not the requirement in case of the coil. So AC in such cases is not preferable, right? And of course, the supply of control system should have less radio interference. Now, alternating current by its very nature is alternating, and it generates alternating electromagnetic forces, electromagnetic fields, which then interacts with the radio signal, which is again not suitable. But when we talk about direct current, this is avoided, or this is much lesser compared to the alternating current. And one more factor if you want to talk about, since we are stepping down a voltage here. So in the auxiliary compartment we have 110 volt DC, 220 volt DC, 48 volt DC. This voltage is much lesser compared to what we are handling, right? So it also provides safety to the operator, because in the low voltage compartment is the compartment where you will go and interact a lot of time, right? So it should also have safety, and that's why it is stepped down to a very small level, or we use a very small value of the voltage there. So if you look at this requirement of the control circuit or the auxiliary circuit, and if we compare the two options that we have, the AC and the DC, for sure the AC will not sustain here, and AC will not give us the output that we want. AC will not give us the desired results that we want. So the choice then goes to the direct current. And that is the reason why in majority of the installations, I would say more than 90% cases, the DC is used. And now if we talk about what IEC standard recommends, now if we look at the IEC 62271-1, which is for the common specifications of alternating current, switchgear and control gear, the table 6 of that states few voltage values, DC voltage values for that. So we have 24 volts, 48 volts, 60 volts, 110 volts, 125 volts, 220 volts, and then 250 volt. Now these are the values recommended by the IEC standard. Now it is possible that if you follow a different standard, different voltages will be there. So let us know in the comment section what auxiliary voltages you have seen or you have experienced in the system. So do let us know that via comments. So I hope you now have clear idea why direct current is preferred for auxiliary supplies or the control supplies over alternating current. If you want to go deeper into understanding and interpreting the control circuitry of a circuit breaker, then definitely do check out my course, Circuit Breaker Control Schematic Masterclass. You'll find link for it down in the description. By the end of that course, you will be able to read and interpret the circuit breaker control schematics of any manufacturer and of any kV level. So definitely go and check that out. If this video was helpful, then do like this video and do share it with the people you think might be interested in knowing. Thank you so much for watching, guys. I'll see you in the next one. But till then, keep watching, keep learning.